Hello again. Today we're going to learn about law of cosines. To solve a triangle, for law of sines, you either need to be given two angles or you need to be given an angle across from a side that you already know. So for example, if they give you angle A, you need to know side A. For law of cosines, you'll be able to solve the rest of them basically. So if you have a side angle side, you're going to be given two sides and one angle, the angle in between, or if they give you three sides. And you can use law of cosines. So you can start the question with law of cosines, and then you'll finish the question using law of sines. So this case and this case, side angle side, 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 side. And so here we go. So the formulas are here. You can notice that they're all pretty much the same. It all depends on which angle they give you. So if they give you angle A, you'll use the top one. They give you angle B, you'll use the second one. And if they give you angle C, you'll use a third equation. If you are given three sides, then you're going to use the variable that is the longest, because you always want to find the biggest angle first if possible. But we'll get to that in a second. So for the first example, again, we're just going to write down the values that they gave us and the values that we're finding. Unlike law of sines, you do not have to check for a second triangle or anything. They're not ambiguous, so there will only be one triangle. So the values that they give us are, they give us that side C is 14, side A is 11, and angle B is 34. So you can notice right away that you have two sides and one angle, but none of the letters match, so you don't have an angle B and a side B, which means you can't use law of sines. So because they give us angle B, we will be using the B squared formula. Okay, so I'm going to do the work down here. So it's going to be B squared is equal to A squared plus C squared minus 2 times A times C. Those numbers, these two numbers always match those two, times cosine of the angle. So if this is B, then this is also B. The 34 degrees is B. They have the beginning and the end of the formula are always the same letter. Okay, so if it starts with A squared, it ends with A. If it starts with B squared, it ends with B. And if it starts with C squared, it ends with C. If you run that through your calculator all at once, then you're just going to do that just exactly how you see it. Please don't use parentheses at this part. Use multiplications. Okay, so 11 squared plus 14 squared minus 2 times 11 times 14 times cosine of 34. Making sure your calculator is on degrees. That's going to give you B squared is equal to about 61.6. And then leave the rest of the numbers in your calculator. Then we're going to take the square root of that. So take the square root of the answer. So B is equal to approximately 7.9. So that's the B value. So that's the law of cosines. That's as much work as you need to show. But you do need to use all of the numbers in your calculator, please. Then we're going to finish with law of sines. So now that we have this, we definitely have sine of B over B. But we need to know if we have to do A or C first. What I need you to do is, when you're doing law of sines, you always want to do the shortest side first, or the smallest angle before the biggest angle. So for law of sines, we're going to do A before we do C, because A is going to be a smaller angle, because 11 is smaller. So we're going to do sine of A over 11. When you cross multiply here, you're going to multiply this times this divided by 7.4. So sine of 34 times 11 divided by 7.4 is going to be 0.778. And then you're going to take the inverse sine of both sides. That will give you that the A value is 51.1 degrees. And then you can add these two together, subtract them from 180, and that'll give you 94.9 degrees. And again, double check at the end that the smallest angle is across from the shortest side, middle across from middle, and the largest across from the longest. All right, so for the next problem, I would like you guys to go ahead and try it. I'm going to wait a second, or you should pause it excuse me, pause this video so you can do the problem first and then come back and check your answers afterwards. All right, you should be done with that, checking that, doing the problem at this point. In this case, they give us angle C, 40 degrees, side B, and side A, which is 20. Again, we have an A, a B, and a C. So we're going to do the C squared formula because that's the angle that we have. So C squared is equal to A squared plus B squared minus 2 times 20 times 25 times cosine of C. If you work all this out, you end up getting C squared is equal to 258.9 and a bunch of other numbers. Then you would take the square root, and for C you get about 16.1. Next, because A is smaller, we're going to go ahead and solve for A second. So sine of A over 20 is equal to sine of 40 over 16.1. Again, cross multiply and then divide by 16.1. So you end up getting sine of A is equal to 0.798. Take the inverse of both sides, inverse sine. So you end up getting A is equal to 53.0 degrees. If you add these two together and subtract them from 180, you end up getting 87.0 degrees. So you should have these as your answer. Okay, so that's the first type where they give you two sides and one angle. All right, so now we're going to continue the video, or start a new video, I should say, about law of cosines. In this case, we're given three sides. So when you're given three sides using law of cosines, you need to start by solving for the largest angle first. And then after you solve for the largest angle, then you will solve using law of sines with going backwards and going back to the smallest angle afterwards. So let's go ahead and write down the information that's given to us. So in this case, we're given three sides, A, B, and C. The largest angle is going to be B because 27 is the longest side. So even in the picture, it looks obtuse. So we're going to start with the B squared formula. So B squared, using law of cosines, is 27 squared equals A squared plus C squared minus 2 times A times C times cosine of B. Remember, if you're solving for angle B, then B squared has to be the first thing you write down. Now, when we're doing this part, this number here, this negative 2 times 12 times 20, is the coefficient of cosine of B. So that number is going to stay with cosine of B. Okay? These two numbers, we're going to subtract those to the other side. So we're going to take 27 squared, and you're going to subtract 12 squared and 20 squared. Okay, so in your calculator, you're going to take 27 squared, and you're going to subtract both of these. I'm not going to show the work, but basically you're subtracting 12 squared and you're subtracting 20 squared. Okay, I guess if you want to write that down, you can. So 27 squared minus 12 squared minus 20 squared should give you 185. If you multiplied all these numbers together here, negative 2 times 12 times 20, that would give you negative 480 times cosine of B. Okay, we cannot add that 480 over. It's a number that is multiplied by cosine of B, so you can't remove it until you subtract the 12 and the 20 over, and now we can divide. So we're going to divide both sides by negative 480. When you do that, you end up getting negative 0.385, and that equals cosine of b. And to solve for b, since it's an angle, you're going to be doing inverse cosine of both sides. When you do that, you get b is equal to 112.7 degrees. That's probably the hardest thing you're going to have to do. You're just going to have to kind of keep track of your numbers. So again, you're subtracting both of these over to the other side. And then you're going to multiply these numbers out to figure out the coefficient of cosine, divide by that number, and then put it in your calculator. Now, when we go to do law of sines, we want to do the smallest of the remaining two. So 12 is smaller than 20. So we're going to do law of sines with a. So sine of a over 12 equals sine of 112.7 over 27. Now, normally I say not to use numbers that we've already rounded, but we can't get away from it. There's no other way to solve this. So we have to use 112.7. So we're going to multiply this times this, and then we're going to divide by 27. So you're going to get sine of a is equal to 0.410. Then you'll do the inverse sine of that. And you'll end up getting a is equal to 24.2 degrees. For the last angle, you just add those two together and subtract from 180. And those are your answers for this triangle. All right, next, you should try the next problem and see what you get. So pause the video at this point, do the problem completely, and then play it when you're ready to check your answers. Okay? All right, so ABC, A is 30, B is equal to 27, and C is equal to 18. So since we're using law of cosines, we want to do the biggest angle first. So we're going to do the a squared formula. So 30 squared equals 27 squared plus 18 squared minus 2 times 27 times 18 times cosine of A. So when I subtract those numbers over, I get negative 153 is equal to, and then when I multiply those numbers together, I get negative 972 times cosine of A. Okay, so again, subtracted these first and then multiplied those together. So these numbers multiply to that. Then I'm going to divide both sides by negative 972. Since both of these numbers are negative, you're going to get a positive 0.157 equals cosine of A, and then you'll do the inverse cosine of both sides. So A is equal to 80.9 degrees. Next, because we're using law of sines, now we go to the smallest side. So when you're using law of cosines, biggest side, using law of sine, smallest. Sine goes with smallest. So we're going to do sine of 80.9 over 30, sine of C over 18, cross multiply. When you cross multiply, you end up getting sine of C is equal to 0.592. Then you'll take the inverse sine of both sides. And you end up getting C is 36.3 degrees. Then you'll add A and C, subtract from 180, and that'll give you angle B. All right, so hopefully you guys were able to do that one correctly on your own. We already found the area of triangles, so that's it for that. So you should be able to go to the end of 9.4 and go ahead and try some odd problems. So you can check them in the back of the book and determine whether or not you understand this material. Please send me a message if you have any questions with this.